Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where I help you to get chemistry confident and help you to get from point A to grade A. Hello, welcome back. It's great to have you back here. I really appreciate your attention and so glad that you find this the place to help you learn some chemistry. And the chemistry we're going to learn about today is about the combustion of alkanes. So we're going to talk about what combustion means. We're going to talk about complete combustion and incomplete combustion, and we're going to talk about why combustion of alkanes in particular is so important. So what do we mean by combustion? Combustion of an alkane is the reaction of an alkane with oxygen. That reaction is usually accompanied by a flame, and there is a great deal of heat energy in particular given out. You may recall from our previous episode on alkanes that I mentioned that the carbon-to-carbon and carbon-to-hydrogen bonds, which are the only bonds that exist in alkanes, are very high energy bonds. So breaking those bonds is going to release a lot of energy. Therefore, alkanes are effectively great stores of chemical energy, and hence they're very important fuels. They're relatively easily portable, and it's relatively easy to get the energy from them merely by combustion, the topic we're talking about today, which is why they're so commonly used as fuels. Gases like methane, propane and butane are the kind of gases that we would use either at home or in a camping stove or so on in order to do some cooking, and also for heating. One or other of those would be the gas that you would use in your home central heating to fire your gas boiler to warm up your home. But they aren't just gases. Things like paraffin, petrol or gasoline, and diesel are liquid alkanes, or rather they're mixtures of liquid alkanes that are very conveniently carried in a can or in a vehicle in order to take a store of energy around with you. Okay, so let's get on with the combustion itself. And we said there was complete combustion and incomplete combustion. We're going to think about complete combustion first because that's what we study most regularly. That's what we want to achieve when we're actually burning those fuels because that will get us the most energy. Complete combustion is the combustion of an alkane when there is a plentiful supply of oxygen. And the products of complete combustion of a pure alkane are only two. There's carbon dioxide and water, no others. Each alkane requires a different amount of oxygen, of course, in order to combust completely. Possible, in fact, required usually, to write a balanced equation for an alkane being considered. And that's simply done by writing the formula of the alkane plus oxygen, write the products on the right-hand side as CO2 and water, calculate the number of moles of CO2 and water based on the number of atoms of carbon and hydrogen in the alkane. And then when you know how much CO2 and water is being produced, you can calculate how many moles of oxygen are required. And that is how you balance that equation. You'll very often see associated with the equation the enthalpy of combustion for that reaction. It's the amount of kilojoules per mole of energy released by burning or combusting 1 mole of that particular alkane. And of course, because energy is being released, those enthalpies are always negative, and because there's a high amount of energy released, they're always a big negative number. Okay, so let's move on to incomplete combustion. What do we mean by incomplete combustion? Well, complete combustion was when we had plentiful oxygen present. So incomplete combustion is where there isn't so much oxygen present. There isn't enough to fully combust the alkane. Now that doesn't prevent the reaction from proceeding. We just get a different reaction, different products. And if we have limited oxygen, if we don't have enough oxygen for complete combustion, we'll end up with a product of carbon monoxide. Sometimes, if there's very little oxygen present, we will end up with carbon. And that is effectively soot. So when you see a flame going out due to a shortage of oxygen, you often see a sooty smoke. And what you're seeing is tiny particles of carbon, of soot. There will always still be water as one of the products. So depending on how much oxygen is present, you may get a mixture of products of carbon dioxide and carbon monoxide and water. You might get carbon monoxide and carbon and water if there is a very short supply of oxygen. Whenever you see an equation for a combustion reaction of an alkane, that has either carbon monoxide or carbon in its products, that's a way of identifying that incomplete combustion has taken place. By the way, when we get incomplete combustion, we won't be releasing as much energy from the alkane as we would in complete combustion. Okay, let's summarise what we've talked about today. We talked about alkanes being a very good supply of energy, and that's why they're commonly used as fuels. They're easily portable and easy to get the energy from by combustion. And the reason for having a lot of energy is that the only bonds present, the carbon-to-carbon bonds and the carbon-to-hydrogen bonds, are high energy bonds. We talked about complete combustion, when there is a plentiful amount of oxygen present with our alkane when we do the combustion. When complete combustion occurs, we only get the products of carbon dioxide and water. And it follows that incomplete combustion is when there is not enough oxygen present for complete combustion, and amongst the products we may get carbon monoxide or we may get carbon as well as water. Okay, that summarises this topic. If you have any further questions on this, please feel free to reach out to me. Best way to do that is within the show's Patreon community. In there, I invite you to ask questions on each episode, and we'll be answering them there for you as well. And to find that, just go to patreon.com/chemistrymadesimple. I just want to say a big thank you to the show's patrons now who are actually supporting the production of the show. There's other ways to get in touch as well. I always like to hear from you. And to do that, you can find me on Instagram at Chemistry Made Simple, or you can email me, matthew@chemistrymadesimple.net. All those links are in the show notes. One thing I'd really like to hear from you about is, what is your takeaway from today's episode? What's your biggest learning point from today's episode? Okay, so all that's left for me to say is thank you for listening. Please go seek out some questions on this topic to help you cement what you've learned today. I look forward to speaking to you again in the next episode, and until then, look after yourself and goodbye.